Andrew Brooks, and today I'd like to present President Garfield's proof of the Pythagorean Theorem. Now, if you've seen my other video, you know the Pythagorean Theorem says that the hypotenuse of a triangle, which is going to be C, this is a right triangle here, equals a squared, that's one leg. The two legs are a and b, so a squared plus b squared. Now, President Garfield was assassinated around 1880, but this is perhaps his greatest accomplishment. I think this makes him one of the greatest presidents ever. What other president in the 20th century or the 21st could have proved the Pythagorean Theorem? Okay, now how he did this was by noting a couple of things. First of all, the area of a trapezoid. Now let's look what we have here. We have two right triangles. You'll notice that one of them has the B side as its base. One of them has the A side as its base. Now I used 3, 4, 5 triangles, and actually this is 8 inches, which is a multiple of 4. This is 6 inches, a multiple of 3. And the hypotenuse is 10 inches, which is twice times 5. So now if we lay our two right triangles in this fashion, and we connect them with a line here, we get a figure called a trapezoid. And the definition of a trapezoid is a quadrilateral with two parallel sides. So you'll notice that these two sides are not parallel. But these two sides are parallel because they both consist of the legs of right triangles. And since they're both perpendicular to the bases, they're parallel to each other. So, the area of a trapezoid, the formula for that is half is actually the average of the bases. And the bases here are A and B. So we're averaging the bases. Now here you have to look at the trapezoid as the bases being this side and this side. And the height, you're multiplying the average of the bases by the height. And the height in this case is this distance, which is B plus A. So we have B plus A. And if we multiply this out, we get 1/2 AB plus A squared plus B squared plus AB. Or you could simplify that to 1/2 2AB plus A squared plus B squared. So that's the area of the trapezoid. Now let's look at the area of the three constituent triangles. The formula for the area of a triangle is half the base times the height. So on this side we'll say 1/2, the base is B, times the height A, plus 1/2, the base is A times the height B, again BA. And finally we have this triangle in the center. And that is 1/2 the base, C, times the height, C. C times C is C squared. Now we know that this trapezoid is composed of the three triangles, so we can equate the expressions that we've computed for the area of the three triangles. And the trapezoid. So let's do that. We have 1/2. We'll factor the 1/2 out of these three expressions. BA plus BA plus C squared And we'll equate it to 1/2 over here, 2ab plus a squared plus b squared. Okay, let's just keep this separate here. Now, we can multiply both sides by 2, and this is going to give us 2ba plus c squared equals 2, ab is ba also, ba plus a squared plus b squared. Well, let's stare at this for a second. First thing we can do is cancel out the 2ba from both sides. And we're left with c squared equals a squared plus b squared. And that's the Pythagorean theorem, which is what we wanted to prove. And that's the end of the proof. Thank you.